Hi, everyone. I'm Doug Black, Editor-in-Chief at Inside HPC. And today we have 4 HPC thought leaders as the SC21 conference winds down. We're going to be talking about some of the more significant sessions, keynotes, news announcements that these folks think were particularly noteworthy this year. With us, we have Addison Snell. He is co-founder and CEO of Intersect 360 Research. We have Steve Conway, Senior Advisor, HPC Market Dynamics at industry analyst firm Hyperion Research. Shahin Khan, Technology Analyst at OrionX.net. And we have Rick Stevens, Associate Lab Director and Distinguished Fellow at Argonne National Laboratory. Gentlemen, welcome.
Well, thank you.
Thank you, Doug.
Thanks for the invite.
I'm glad we have amongst us one person who knows what they're doing. That would be you, Rick.
I guess.
In fact, Rick, let's start with you. You let me know you attended about 20 sessions so far this week. What in particular caught your eye?
Well, I liked Anima's talk on AI for science. Of course, that's something that I'm spending a lot of time on these days. So getting her perspective was quite good, and I thought raised a lot of the issues. I was very impressed by some of the sessions that were more on the softer issues. You know, the ethics session, the sessions on women in HPC, and other topics. You know, kind of raising the diversity issue and inclusion issues. I think that was very important. China was pretty well represented in the sessions. I thought that was quite interesting. A number of talks from folks working on the Sunway, including, of course, the Gordon Bell Award. Yutong Liu gave a nice talk about convergence. And of course, AI was kind of all over the agenda in various places, a lot of GPU-based talks, and a little bit of quantum. So I think it was a little bit of everything for people. It was very difficult, to get the buzz of the conference. When you're there in real life, you hear in the hallway like what people are echoing and what's going on. I think it was a little bit hard to get that sense in these virtual meetings, but there's still a lot of excitement. The Gordon Bell talks were uniformly excellent, and I think they made some good decisions. So of course there was a couple things missing. We didn't get any news from Oak Ridge on the new machine, but that's we're still pushing forward on that. There were some announcements last week that I think gave some context both over the last couple of weeks, right, about where things are from AMD, for example. That was nice. And a lot of the vendors kind of held back. So, but I think overall it was a really good conference and a lot of nice participation virtually from students, and overall a good week.
Okay. Great stuff. Now, Shahin, I know you were particularly interested in sessions on quantum. What did you hear?
Yeah, so this year for me was quantum computing and HPC on edge. Those are the two areas that I was focusing on. The tutorial on quantum computing was highly well attended and was wonderful. And then there were several sessions during the week. Some of the noteworthy stuff really is the synergy between quantum computing and HPC. It is noteworthy that quantum computing vendors are very happy being an accelerator hanging off of a supercomputer. They don't have the same kind of an identity crisis that GPU people did, kind of wanting to be the main act. They're okay being a co-processor. And I think that will help the integration of the two. So that's one thing. The second thing is that quantum inspired continues to be way ahead of quantum real. And quantum inspired is like leading to all sorts of simulations of quantum computing and simulations of how quantum computing and HPC can work together, either cooperatively or sort of one sets it up for the other. And all of that is very, very, very interesting. Now, the reality of quantum computing continues to be all over the map in terms of the various technologies and the software stack, but it's all really making great progress. So the usual overhyped and underestimated continues to be true.
Well, maybe quantum doesn't mind being in a complementary role because it knows whatever it does, it can do better than classical, right?
I hope so.
So, Steve, what would you say were among the important market developments and the major vendors were focused on this week?
I would say that in the meetings with the major vendors, the biggest topic was, and Shahin mentioned this, edge computing, and over time, you know, the expectation that that's going to really reorient the HPC ecosystem, and for the first time, kind of move HPC from what it's always been a niche market into having a crucial role in the mainstream global IT infrastructure. So that's an important new opportunity for vendors, and you know, that's what people seem coming and are kind of preparing for on the vendor side, is exactly how that will happen, how soon that will happen. And you know, we're already seeing several large vendors roll out metaverse, whatever they call it, metaverse initiatives that are meant to accelerate and exploit that, but that they see really changing the role of lots of folks from CSPs to the systems vendors and the relationships with each other. And that's what we mostly talked about with the vendors. And of course, that has very important implications for AI.
You know, it's funny you mentioned that, Steve, because yesterday's announcement, NVIDIA's quarterly earnings were pretty spectacular. And, you know, they're really pointing at the metaverse. And I don't know what you all think, but I think metaverse could be as you were just saying, really, Steve, that it's an instance where HPC plus AI is really going to very likely enter into the lives of everyday people, you know, well outside of the tech industry.
If you're going to pick a digital twin planet, probably start with Earth, and they do.
Yeah. However, I did a search on the SC site. Metaverse did not come up that I could see. I thought that was kind of interesting. Maybe
it's probably a good sign. Metaverse right now is highly aspirational, to put it generously.
Yes.
And of course, to the extent that it is real, it's going to need HPC, because Addison would know from, you know, one of his lives about, you know, the whole idea of making immersive graphics is not new. To do application steering through visualization is not new. And in fact, when you have, you know, my joke used to be that if you have 200 rows in your spreadsheet, it's a spreadsheet. If you have 2 billion rows, it's HPC. So the reality is that nothing in this day and age is not going to be HPC. And I think that's the recognition that the business world is starting to get to, and maybe even some of the HPC community might start to get to, because usually we are not quite in the leading edge of that. We don't mind building stuff and handing it over to other people to go make money off of.
You're right. Even when Addison was a SGI, and I was an SGI person for a while too, is, you know, they had pretty impressive synthetic reality experience.
Yeah, it was, you know, Project Holodeck. You know, we are trying to build the Star Trek holodeck, and of course the cave was another one of those.
Yeah, we worked on this in '95, right? If you remember Supercomputing '95, where we did iWay, where we connected 60 plus groups, VR, multiple VR installations, distributed VR, linking to simulation. So yeah, we've been there before. It's all high performance computing at the end of the day, high performance networking. And so I think it's pretty bright. You know, there's a reason that mainstream is moving quickly into broadening the HPC applications and deep learning applications of their GPUs, and pushing, you know, AI acceleration concepts into general purpose hardware as it all starts to converge. You know, the SC conference series, and of course the community that works HPC is going to be essential for the development of all of this. So I think it's only going to go up. We just need to get a lot more people and a lot more diversity in the HPC community. I think that's the other big issue.
Just one more quick note is that not much is brand new. I mean, the people were talking about, you know, HPC systems being used to read MRIs with superhuman ability. Well, George Mason started doing that with supercomputers routinely in 1993. So it's been around a while.
Okay.
Well, I think for me, when I look at the NVIDIA metaverse announcements, I really like the long-term vision of what AI can do, but I get concerned about, can you also sell me what's available today and meet the market where it is? I can buy into the long-term vision, but Earth 2 as a project was not a lot more than it did. They have more that they can announce about, what it is and where it's going to be and what it's going to do. From the NVIDIA announcements, I thought the more practical announcements that really affected things today were the Mellanox NDR InfiniBand, as well as I really liked Q-numeric, which is going to do for Python what CUDA has been doing for C and C++, which in our surveys, Python is now one of the major languages for active HPC development, which is a real shift from the past. Now, not every company that's got a big vision going forward is really connecting that to where we are today. So I look for those details. And of course, NVIDIA wasn't the only one with news. AMD had the big news with Milan X and MI200 about 2 weeks ago. I thought we would hear more about that during the show than they did. I thought AMD would hire a band or something to march around the show floor. And that was kind of surprising that we didn't get more on that. I liked the Intel keynote from Jeff McVeigh at the start of the show in their virtual HPC and AI pavilion, using phrases like fire-breathing performance monster that brought a little swagger to Intel that we haven't heard in the past few years. So I'm serious. I
think that's Pat's influence, right? You've now got another engineer at the top. So you've got the three main tech providers, all with strong engineering leadership all the way down, and that's going to affect the competitive spirit between all of them. And of course, it's going to heat up, right? Over the next couple of years, we're going to see a lot of really hot competition between those three companies.
Absolutely. Used the phrase "we engineers," right? And that just those two words there did a lot.
Well, I was surprised in the AI realm that, or at least I didn't see it. It may have been there somewhere that there wasn't more about the methodologies and the increasing and raging debate that's out there that we hear about how long how far will deep learning take us before it needs to be augmented with other methodologies because of its limitations? And so I expected to hear a lot more from the other contingent within AI that's kind of pushing for those.
So SC, of course, isn't a primary conference for the AI research community. If you've been tracking the three big AI conferences over the last couple of years, they're huge now, and the quantity of papers is just enormous. It dwarfs supercomputing in terms of the scale of papers. The big news there right now is transformer models are still got a lot of lifetime in them. There are a lot of algorithms. There was actually a paper here in this conference about moving away from the quadratic performance problem of transformers. And Anima's talk also mentioned this continuous functions, or basically infinite networks. So there's some progress there. I think we're going to see a gradual evolution of deep networks. We're not going to see some kind of cliff. There's just so much progress being made that's driven by scale and driven by performance of the hardware, and so many new ideas that if we have this conversation 5 years from now, we'll be talking about something different. It probably won't be transformers anymore. It'll be something else. But I think progress is going to continue for quite a while. There's no AI winter in sight.
No, not at all.
No, I would agree. I just meant because it so happened at the same time Irvin Ladowski Berger of IBM fame a while ago put out a very nice one about the learning models not being able to deal with cause and effect that's so important for science. And so forth. So
causal inference is that's where that's going. And they're it's heating up. So I think it'll get absorbed, and symbolic reasoning is starting to get bridged over to transformers and large language models, which are being now applied to imaging and to structured, all kinds of things. So I think it's really getting mixed up in a good way.
The thing I was looking for, and I found a little bit of it, but not a lot of it, was the data side of AI. Because I think the compute side has got a lot of attention over the past 10 years, but the data side hasn't. And I think that is increasingly going to be where the problem is. And of course, ultimately, data and the quality of data and the validity of data and reproducibility and all that other part of data will be the ultimate the barrier. At the end, you kind of have built the engine, and the engine is right, and you need to run clean fuel through it. and data is the fuel, and we need to do that. Now, there were several talks about storage, about like, even the 53 petabytes NVRAM that they're doing at I think it is NERSC that they're doing. It's all wonderful stuff, but I didn't really see enough about the data supply chain, as I call it. Is that what does it take before I get data off of the sensors and I now have AI ready data? And all of that is just to train the model, and that's just the way station before you do something with the learning. Right? How does that mean with the inference, and how do you provide clean data? Stevie and I were talking about this to the whole end-to-end piece. And of course, when you think about it end-to-end like that, edge computing and HPC shows up.
Yeah.
And I was very pleased. I mean, people really are, in a way that they weren't so much a couple of years ago, paying more attention to the inferencing side too. That's really coming along much better, because that was sort of a little bit neglected as people focus so much on the training side.
Okay.
Yeah.
Go ahead, Rick, please.
Well, I was just going to say, we haven't seen a lot of, I'd say, end-to-end deployment stories yet, right? So we have hardware architectures, a lot of the speeds and feeds are making progress, and we have a lot of focus on training and maybe some numerics. But soon, hopefully, in the next few years, we'll start seeing talks that are really about, all the way from the data to a deployed AI system that's changing how you do something in the science and technology space, right? And I think that's really what we have to push on and kind of set our expectations, higher, right? Just papers that just talk about, I create a new algorithm, I train a model, that's not sufficient anymore. I want to see some impact, right?
Yeah.
Good point.
Okay, now sticking with you, Shahin, I know you had some thoughts on the top 500.
Yeah, I think I'm boring everybody with my top 500 perspective. I think there will be bingo games designed around what I say, and I keep repeating. I think top 500 is critical for the community. It's a wealth of information. It's multiple decades of data, historical record that we can compare against. And when I have the performance for them HPL, I'm not going to look at HPL to decide whether to buy something or not, but it's a very significant data point combined with the system architecture and the configuration to learn from. And I think we have learned a lot through top 500. When Fugaku shows up, we learn a lot. Oh my God, they did it like this. When other systems show up, we learn a lot. So I think not playing is just bad form. I think that to try to play without playing is even worse form. And I think that we as a community need to recognize that top 500 is not supposed to be the exhaustive, conclusive account of all the big systems out there. There were always systems that shouldn't have been there, and there were always systems that should have been there. That part is not new. What is really enduring is what we learn from it. And then you got the HPCG, and then you got the HPLAI, and then you got the other few things. And then you can start putting your arms around what you're dealing with and what this means for the system architectures of the future. So that's what I think. So I'm a thumbs up on top 500. Keep it up.
I agree. The top 500 is very important as a census of things happening to the largest systems over time. That's where it's really very, very valuable. And beyond that, as sort of some sort of a common performance. I mean, you could run it on a washing machine. So it's very important for comparing different kinds of computers. The problem has been that it, and I've said this before, that it doesn't come with a warning label like a cigarette pack. And so people misrepresent, or in their minds, they're not really sure how to interpret it, and it's widely interpreted as representing more than it was intended to represent. And in any case, I think China, for whatever reasons, and people speculate back and forth, did a sort of a good job of defanging it this time.
Yeah, I don't know about that. I think that playing is the right thing to do. I think the HPC community is global and wants to learn and wants to advance. And it's a really great way to contribute to it. I think that, taking advantage of community stuff rather than contributing to it is, now, of course, they did have, specifically, but I'm not even talking about China. There've been, through the history, there've been several players who kind of want to do it without doing it. And I think that's really not cool. I think the whole purpose of it is learning, and we need to recognize it that way. And if it gets misrepresented, well, then we need to talk to those people and say, don't misrepresent it. Don't misinterpret it. I think for people who have been tracking it for a while, they know what those numbers mean. If I have the system configuration and if I have HPL, I can already make 3 other conclusions that are in the ballpark. now give me HPCG, I can make 2 more conclusions that is in the ballpark. So it's kind of like an athletic thing. And, you need a decathlon to kind of size up the whole athlete. But, with one track, with one particular event, I can already start getting a feel. And I think that's highly valuable. So I really don't like piling on top 500 because I think what it does an excellent job of.
Not piling on it, but I mean, I think
no, you're not. Others
NCSA made a nice statement that maybe had to be made by not participating at a certain point and focusing on the applications instead. But yeah, you're right. I agree. In the long run, it's very valuable.
Yeah. So I'm not suggesting that everybody should participate. I'm saying that if you've got other fish to fry, or if you've got confidentiality issues, by all means, don't participate, like a lot of other people who have not participated. But you can't play without playing.
Sure.
For someone who doesn't want to pile on, you're spending a lot of time talking about it, Shahin.
I'm trying to defend it, man. I'm the defender of top 500. My position is clear.
Addison or Rick, do you have any top 500 thoughts?
Well, I think one of my big surprises from the conference was how much we did learn about the Chinese Exascale systems. I thought that we might go through the week and they would remain largely secret. You were talking about important panels earlier. I think the fact that David Kahaner from ATIP gave a talk talking about those architectures for the systems at the top of the list, including a third one that was delayed by supply chain issues. The fact of the matter is that if you look at systems that aren't on the list, the top 2 supercomputers, including the first 2, which are the first 2 exascale systems, 4 out of the top 5 and 6 out of the top 10 systems are in China now, and largely based on entirely Chinese technology. And on the list or off the list, that's an important trend. And I like that we were able to learn so much about those systems. And regarding other things that happen in the show that I really like, Rick was talking about talent development and diversity. I always like to get a plug in for student cluster competitions. Mm-hmm. This was my first supercomputing together with Dan Olds as our new chief research officer, and he's been a longtime supporter of all of the different student cluster competitions at this conference and others. And we also have now adopted a student cluster competition that he launched on his own previously. We'll be supporting it, Intersect 360 Research, that specifically outreaches to HBCUs and other minority serving institutions. That's coming up around as a virtual cluster competition. You can find information about that, not even just on our website, but its own presence at winterclassicinvitational.com. Really happy that Dan is able to continue those efforts and work on the talent development and diversity in this industry.
Good stuff.
That's great. That's great stuff. Now, Steve, I know you had some thoughts about government support for HPC. Any big changes there?
Well, like most of the people on the phone, we've been in the community for quite a while, but it's kind of new in the last somewhere between 5 and 10 years, where governments for the first time around the world are really seeing HPC as important for economic competitiveness, GDP growth, as well as science and engineering research. And boy, if you read the submission to the European Council for the funding, you barely saw the word science. You saw a lot about economics and industry and all the rest of that stuff. Maybe that went a little bit too far, but they got the funding. And so that's really new. But accompanying that is what is so strategically important now to the governments, that what you're seeing is these domestic initiatives to build up their own supply chains and to make sure they're not going to be heavily dependent on foreign sources. And that can be a positive thing and maybe a little bit disruptive in the meantime. But ultimately, what gets to be important is that researchers can get access to the best supercomputer resources in the world, no matter where they come from. And that's going to be a struggle with some of these initiatives. You saw in Barcelona that kind of blew up that way. But an interesting development. There should be more choice in the market over time as these initiatives take root.
I'm hoping this alignment with economic development and competitiveness will help justify these increasingly humongous investments. Because as we get to exascale, and now we're pretty comfortable with several $100 million a system now. And as we go up, it's just going to grow. And that sort of is important that we're able to justify these investments.
Well, you raised the topic, and it'd be good to hear from others on this call about that and this is something in the meetings with the major vendors, are we going to be continuing? Are they going to be continuing to build really large monolithic systems that can do everything, Swiss Army knife systems, or are these things going to be more composable? And I don't know what others have heard there.
Well, that's an active topic of discussion. Of course, it's partly technical and partially business model issues that are blended here, right? One of the nice things about having very large general purpose machines is that they give you a platform for experimentation that is easier in some sense than if you have a lot of maybe smaller heterogeneous machines or more special purpose machines. So I think they're essential to the research community because they give you a time machine to experiment and try things that you can't do if you don't have machines like that. Whether or not the business models for these large systems will continue to work is a question. It's partially even a question if they work now, because it's very difficult. I mean, to do exascale systems, as you guys know, we've been working on them for a long time in the US. The first workshop we ran on that was in 2007, and now we're just getting machines deployed. The integrator market seems to be somewhat less diverse than it used to be, so it's not clear how sustainable this is going forward, and the community's got to really rethink what are alternative models for getting what we need to drive research forward. Because ultimately, it's research, right? I mean, it's the systems and top 500, all this viewed somewhat as a proxy for, either industrial strength or vitality or whatever in national agendas. But it's fundamental to making progress in research, whether it's physical research or healthcare or whatever, right? Climate. So we need to make continued progress on systems, but we do have to figure out a way to do it so that we're not at very high levels of risk. I mean, if you start building $500 million machines and you fail, if you fail a couple of times, it'll be very difficult to keep going with that scale investment. So we have to both have increased diversity, take risk, but also somehow find a way to continue progress at scale without putting the whole community at risk. And that's a tough order, but that's kind of the agenda for the next 10 years is how do we do that?
Well, I think what I heard from the big vendors we talked to is that very much consistent with what you're saying is that, where they're heading is to continue to build large systems, but to make them within the systems more composable, the resources, and with our friend software.
Well, Steve, I think it was your colleague Bob Sorensen who said to me, to Rick's point, building these absolute push the envelope systems, but you better not fail. It's kind of it's a tightrope.
But Doug, the flip side of that is that you are good at what you keep doing and what you keep investing in. Mm-hmm. And that's the thing, is that if you don't keep doing it, you're never going to be good at it. And I think being good at exascale systems is mandatory. It's an imperative. There is no other option. We must really, really be good at this. So good at it that we can do a half a dozen a day and be good at it, because that's, by God, what we're going to need to do 10 years from now, 20 years from now.
I think Shahin's absolutely right, Shahin. And plus, we have to train a whole new generation of workforce on how to do this. So if the landscape becomes so concentrated on only a handful of companies that know how to do it, and they keep it a secret sauce, then you have no way to really train. You have no way to drive systems R&D and computer science departments around what we learn from these machines and so on. So there has to be kind of a public-private enterprise that's doing it, and we have to do it with enough diversity that we can train a whole generation in the workforce, so that this knowledge gets built on and grows rather than becomes thinner and thinner over time, right? And we're all getting older, and there's not that many people that have been in this business for 30, 40 years that kind of see the transition, but we've got to find another 20,000, 30,000 people to plug in to keep driving this forward. Otherwise, things will stagnate. And the other, I think, really magical thing about HPC, at least in my video wedged, is that the blending of scientific computing with HPC has been the traditional sweet spot of this conference and the community that we're in, right? And of course, now that HPC is becoming a critical enabler of AI, many use cases coming from AI don't have this scientific component to them. They don't have the back and forth, the co-design, deep integration with underlying algorithms in science, and that's going to change the kind of complexion of HPC. But we have to retain, connections to the broadest possible use of this technology. So it can't just become narrow around driving AI. It still has to be broad about driving the entire research enterprise, the engineering enterprise, the commercial enterprise, and that's going to require some work, to keep that breadth as we go forward.
I think things are going in the right, in a better direction, because the architectures are starting to get a little more balanced than they were. They were getting so compute centric, flop-sided, that every new generation arguably was getting to having a narrower breadth of applicability, or at least that's what some of the leaders were saying that we heard from. And I think things have shifted and are starting to get in a more reasonable direction there.
Balanced perhaps, but also as they've gotten more and more heterogeneous and needing to serve multiple workloads with traditional scientific computing, analytics, now artificial intelligence. I have different configurations that I want to use for those different things. We've had in the short term a lot of over provisioning of those sorts of components. And one interesting topic I've heard a lot about building up through this year and heard a lot about at the show is composability, which is an old topic, but it seems like it's starting to come up a lot more, not only with standards like CXL, but we see vendors in this space like Gig.io and Liquid and others that are offering composable solutions. And I'm just getting the sense that composability is going to be a topic we're going to be hearing more about in the next few years.
Boy, did you bring up something, because I didn't think of it before, but I mean, that's probably the single thing that I heard most from vendors is how much more complex their lives are now in making choices and placing bets. It used to be chocolate, vanilla, or strawberry. Now it's like 28 flavors.
That's exactly good. All right. Well, gentlemen, Rick, Shahin, Steve, and Addison, that was a great discussion. Thanks so much. And we'll talk again soon.
Thanks, everyone.
Sounds good. Thanks.
Thank you, Doug.